IB Physics M2025, Time Zone 1, SL Paper 2, Question 1. A box of mass 1.2 kilograms is lying at rest on a surface. The coefficient of static friction between the box and the surface is 0.36, and the coefficient of dynamic friction between the box and the surface is 0.28. For part A, we're asked to outline why the coefficients of friction have no units. Well, the coefficient of friction is defined as the ratio between the force of friction and the normal force. And what is the unit for the force of friction? Well, that is a Newton. And then what is the unit for the normal force? That is also a Newton. So the units cancel. And that is why the coefficient of friction is dimensionless. For part B, we're asked to show that the minimum force needed to accelerate the box is about 4 newtons. All right, so what causes acceleration? Well, force is what causes acceleration. More specifically, a net force that is non-zero. So think about it this way. You have a box, and you're pushing on it to the right. Now, opposing your motion is the force of static friction, right? Because it's initially at rest. And the force of static friction will exactly oppose your push up to a certain point. And that is the maximum force of static friction. So I'll write that as Fs max. So after that point, the box will begin to slide, and instead of static friction, it'll be dynamic friction or kinetic friction, whichever you prefer. So what is this maximum force? Well, that is the coefficient of static friction times the normal force. And what is the normal force in this case? Well, you have the box, right? And since it is on a horizontal surface, it's just going to be the opposite of weight. Weight is mg. And then you have the normal force acting upwards. And its magnitude is also mg. So mu sub s times mg. And we know all of these values. Mu sub s is 0.36. That's given to us. The mass is 1.2 kilograms. That is in SI units already. So we don't have to do any conversion. Then the value for G on Earth is 9.8. So if we multiply all of these, let me pull out my calculator here. We get 4.2336 newtons. And that is approximately 4 newtons, right? And one significant figure, that is 4 newtons. All right, moving on. A force of 14 newtons acts on the box for 0.35 meters, as shown. The force is then removed, and the box continues to move. The box comes to rest after a further displacement d. For part C, we're asked to determine d. All right. So once the box is moving, kinetic friction applies. What is kinetic friction? Well, let's calculate that. That is equal to the coefficient of kinetic friction times the normal force, which again, since we're on a horizontal surface, is mg. And we have these values. It's going to be 0.28 times 1.2 times 9.8. So let me calculate this. And I get 3.2928 newtons. But then we also have 14 newtons acting to the right. And this frictional force, this force of kinetic friction, is opposing that motion. So our net force is going to be that 14 newtons minus 3.2928. So that is 10.7072 newtons as our net force. So where do we go from here? Well, also recall that the net force is equal to ma. And we know the mass. The mass is 1.2 kilograms. So if we divide our 10.7072 by the mass of 1.2, we will get the acceleration. So the acceleration is roughly 8.92 meters per second squared. And now we need to apply kinematics because it is pushed for a distance of 0.35 meters. So the kinematic equation we're going to want to use is v squared equals u squared plus 2as. U is the initial velocity. Since it is at rest, the initial velocity is 0. So we have 0 squared. Our acceleration we found to be 8.92. So I'll substitute that in. Then it's times s, and our s is the displacement, which will be 0.35 meters. So v squared is equal to, let's see here, 6.244. And then we don't really need to find this, but let's find the velocity for good measure. The square root of that is about 2.50. Right. So where do we go from here? Well, once the force is removed, kinetic friction is the only horizontal force, and it is causing negative acceleration. In other words, deceleration. So let's calculate our new acceleration. This time, our acceleration is the negative 3.2928, which we found right here. Now it's negative since we're decelerating. Acceleration is negative, and it's divided by 1.2. So what I get is negative 2.744 meters per second squared. And then again, we're going to want to use kinematics, and we can actually use the same equation. And this is why I was saying we didn't really need to find velocity, because we have velocity squared equals u squared plus 2ad. We only need the velocity squared because we can substitute our velocity squared of 6.244 right here in for the velocity squared. Actually, that's not true. Our final, v is our final velocity. So it's going to be 0, right? Because we're asked to determine d, which is the distance it takes for the box to come to rest. So the final velocity is actually 0. but our initial velocity is that 2.50. Other than that, it's squared. Yeah. So instead of for v, it's for u. Sorry about that. But then we also have the plus 2AD again. So acceleration we found. And we do not yet know the value for d. That is what we're trying to solve for. So if we subtract 6.244 from each side, then divide by 2 times negative 2.744. That is what our value for d should be. So let me plug that into my calculator real quick. And I got that d is equal to 1.137755102. And let's see, how many significant figures are we looking for? So we're looking for 2 significant figures. So our answer would be 1.1 meters. Yeah, so that's the value for d.